Bismillahirrahmanirrahim. Student, today we are going to discuss very important topic, domain and range. Very important concept of this chapter, the function chapter. First, we are going to define what is domain and range. Domain means all possible input values for which function is defined. Later on, we discuss, elaborate, define. Range means all possible output values. When we put domain values in a function, as a result, as an output, we get values, and those values are called range. So domain is all possible input values for which function is defined. Range, all possible output values. So we are going to discuss this concept in detail. When we are finding domain and range, we use number line. And we discuss only real valued function. Number line, and we discuss only real valued function. By real valued function, we mean that we choose a domain from a number line. By real value, we mean we choose a number from a number line. So this is your real number line, and we choose domain from this number line, any value from this number line. That's why we say that we discuss only real valued function. When we find domain and range, we come across two types of conditions. One by one, I will discuss these conditions with you. The first condition, for example, we have function f of x is equal to 1 plus x. Second example, if we have radical function x plus 1. And third example, if we have function like this, x square minus 1 over x plus 1, this function. Now here is our example number 1. The function is f of x is equal to 1 over 1 plus x. Here you can choose any value from this number line as domain, but avoid such value which make the denominator 0. For example, if we put x is equal to minus 1, what will be the result? F of x 1 over 1 minus 1 by 0, the result is infinity, undefined. So whenever you dealing with rational function having denominator, you should keep in mind that you should avoid such values in domain for which the denominator becomes 0. Here I have shown the example. If you put here minus 1, the result is 0 in denominator, and the value will be undefined. So whenever you dealing with rational expression, avoid such values in denominator for which denominator becomes 0. Secondly, you remember, for radical, our second example is radical expression. If we have a radical expression like under root x plus 1, keep in mind you will not take such values as domain from number line for which the value of the radicand becomes negative. For example, if we have a number line, you are familiar with it, 0, minus 1, minus 2, plus 1, plus 2, and so on, up to infinity and up to negative infinities on the left side. Now I can choose any value from this number line, but I will avoid such values as a domain for which the radicand becomes negative. For example, if I put here minus 1, the result will be 0, acceptable, no problem. But if I put here minus 2, the result will be minus under root, and that is iota. Similarly, if I put here minus 3, the result will be minus 3 plus 1 minus under root 2, that is under root 2 iota. These values are not acceptable as range. Keep in mind, whenever you're dealing with radical function, keep in mind you will choose such values as domain for which the radicand give the positive answer. Now here is our third example. Function is x square minus 1 over x plus 1. It is also a rational expression, and you will not put any value in denominator which makes the denominator 0. And if we check the number line, if we put minus 1, if we put x is equal to minus 1, the result will be minus 1 square minus 1 over minus 1 plus 1, 0 over 0. It is called indeterminate form. Indeterminate form. So you avoid such values in denominator for which denominator becomes 0, and you will get this type of form 0 by 0. It is indeterminate form. So as I told you, whenever you are dealing with domain and range, especially radical function and rational function, so you should keep in mind your radicand will always positive in case of radical function, and you should not put such value for which denominator becomes 0 for rational function. So these two important points that you should keep in mind. Number one, denominator not equal to 0, and number one, the expression under the radical sign should be greater than or equal to 0. These 2 points you should keep in mind when you are dealing with domain and range, that denominator of the function should not equal to 0 and the radicand should be greater than or equal to 0. By using these basic things, we solve few questions. Now let us discuss the question of the exercise 1.1 and 1.2. Now here is our first question. The question number 4, first part, question 4, first part, exercise 1.1. The function is 2x minus 5, simple linear algebraic function. Here first we check for denominator and radical expression. You can see there is no denominator involved and there is no radical expression involved. So we are free to put any value as domain from a number line. That is our number line. The number line is 0, plus 1, plus 2, plus 3 up to infinity, minus 1, minus 2 up to infinity. You are free to put any value as domain in this function. There is no restriction because there is no denominator and no radical expression. So we can put any value from this number line. So for this function, domain will be minus infinity to plus infinity. It is called open interval. The values between minus infinity and plus infinity are included as domain. So you can choose any values between these values as domain. There will be no issue. And in case of range of gx, as you can put any value from number line to get as a domain, as a result you get range any real number. So your range will be minus infinity up to plus infinity. Between minus infinity and plus infinity, any value, as it is open interval. When we use small brackets, it means this value not included, this value not included. Between them values are minus infinity and plus infinity. All values between minus infinity and plus infinity are included. For example, if I like write in this way, 5, 20, it means neither 5 include nor 20 include, but between 5 and 20 you can choose any value, that is 6, 7, 8 and so on. So it is called open interval. Now we discuss another question, the question number 4 part 5. The question number 4 part 5, it is piecewise function as it is divided in 2 parts. The first part is 6x plus 7, and second part is 4 minus 3x. 4 minus 3x. And there is restriction. In first part, the restriction is x is less than equal to minus 2, and in second part, restriction is x is greater than minus 2. X is greater than. Now it is piecewise function as it is divided in two parts. First part is 6x plus 7 and the second part is 4 minus 3x. It means function performing its working in two steps. That is why it is called piecewise function. In piecewise function, here you can see we have two restrictions. If there is no restriction, then there is no issue. You can choose any number from number line. But as there is a restriction for value of x, so we are restricted according to these values. So 0, plus 1, plus 2, plus 3, minus 1, minus 2, minus infinity, and plus infinity. Now, as we are given the piecewise function, the first part is I label it as y1 is equal to 6x plus 7. The condition is x is less than equal to minus 2. It means you can choose any value that is less than or equal to minus 2. It means here we can choose any values where x is less than or equal to minus 2. So you will move towards left hand side, minus 3, minus 4, and so on. Now what will be our domain? Our domain will be domain y1 minus 2 to minus infinity. Minus 2 to minus infinity. Our domain will be from smallest to greatest value. Our domain will be minus infinity to minus 2. You can choose any value from minus 2 up to infinity. से पहले कोई भी वैल्यू आप चूज कर सकते हो as domain. It's okay, fine. We are not here free to choose any value because there is a restriction. Values of x or for domain there is a restriction. So we are restricted to choose values or domain from these values. So we can choose values from minus 2 or less than minus 2. And what will be its range? The range will be range y1. What will be its range? If we put the value from this interval minus infinity to minus 2, let us see what range we will get. If y1 is equal to 6x plus 7, so we put minus 2, so we get value as minus 5. For minus 2 we get minus 5, and for minus infinity we get minus infinity. So our range will be minus infinity to minus 5. As minus 2 is included, so answer of the minus 5 or the range of the minus 2 is also included. So minus 5 is also included. It is called it is called closed interval. And we are using, when you are using closed interval like that, 2 and 10, it means 2 and 10 are included. The values will be 2, 3, 4 and so on up to 10. So 2 and 10 are included in the answer. In a similar way, minus 2 included, minus 5 included, but minus infinity and minus infinity in both cases are excluded. Now we take second part of the function. The second part of function we label it as y2 4 minus 3x. The condition is x is greater than minus 2. Now you can choose value that are greater than minus 2. So let us check the number line. Let us check the number line. That is our number line. 0, minus 1, plus 1, plus 2, plus 3, 4 up to infinity. Minus 1, minus 2 and minus infinity. Now as here is mentioned that x is greater than minus 2, so you will move on this side. But let us see if we put different values for this condition, what's happened here. F of x, or you can say y2, does not mean, it is just a representation. If we choose minus 2, although it is excluded, but let us see what is the value. The value will be 10 if we choose minus 2. If we choose minus 1, the value will be plus 7. If we choose 0, the value will be 4, plus 4. But if we choose 1, the value will be positive 1. But if we choose value as 2, so 4 into 3 into 2, the result is minus 2. If we choose minus 2, if we choose minus 3, the result will be, yani you can see from here onwards 2, 3, 4, you will see that you will get the negative values. For this. But here condition is, what is the condition? That x is greater than minus 2. It means greater than minus 2 as you going towards right. As you are going towards right, maximum value you can get, that is 10. Otherwise you will see that your values will be negative as you move around. So what is the result of the domain? We can choose from here. Our domain will be, now domain of this part will be minus 2 to plus infinity. You can choose any value, minus 2 excluded, minus 2 up to plus infinity. And as I explain you, the range y2 will be, what will be the range? As I explain you, the range will, for range values of y2, you can see from this example that maximum value you attain over this interval is plus 10. Otherwise, as you goes on towards right, you can see that the values becomes negative. You will get negative, yani you will move towards left side for range value. Maximum value is 10, and as you goes on, you get the negative infinity. So your range will be, for this question, your range will be minus infinity to plus 10. Plus 10 excluded, as we get plus 10 on minus 2. Minus 2 is excluded, that is why plus 10 is also excluded. That is your domain and range for second part. Now when you are writing the final answer, you will combine range of both parts and domain of both parts for final answer. So domain of gx finally will be, minus infinity to, for first part as we calculated, union minus 2 to plus infinity. That is our domain. And for range, and you can the total domain of the function gx. Now for range, in a similar way, we find range. The range will be, for first part range, that is minus infinity to minus 5 square bracket union minus infinity to plus 10, and you can combine it as minus infinity to plus 10. That is your final answer.